Now part number 3, f of x is equal to 5x square minus 6x plus 2. Solution: first derivative is 10x minus 6, second derivative 10. For stationary points, put first derivative is equal to 0 and find the value of x, which is 6 by 10, and by simplifying that will become 3 by 5. This one is value of x. Now put x is equal to 3 by 5 in second derivative, and as second derivative is the constant function, so will remain unchanged, which is 10, and that one is greater than 0. So f has relative minima at x is equal to 3 by 5. Function has relative minima, so function, we can say the function has minimum value at this value x is equal to 3 by 5, and find that particular value or that particular minimum value, we put this x is equal to 3 by 5 in our given function. So put x is equal to 3 by 5 in this given function, and by simplifying that will become 1 by 5, and already we discussed or we declared that this is a minimum value, so this is the minimum value of the given function. Part number 4, f of x is equal to 3x square. First derivative 6x, second derivative is 6, and for stationary points again put first derivative is equal to 0, and from here we will find the value of x, which is 0, and put this x is equal to 0 in our second derivative, and then second derivative will again be a constant function, so giving a value of 6, which is greater than 0. F of s has relative minima at x is equal to 0, and find that minimum value, put this x is equal to 0 in our given function, so f of 0, 3 into 0, so f of 0 will become 0, and that is a minimum value of the given function. Fifth part, 3x square minus 4x plus 5. First derivative is 6x minus 4, second derivative is 6. For stationary points, put first derivative is equal to 0, and from here we will get the value of x, which is 2 by 3, and put this x is equal to 2 by 3 in second derivative, and as second derivative is a constant function which is a positive number, so we'll return a positive value, so that second derivative is 6, which is greater than 0. So f has relative minima at x is equal to 2 by 3, and to find that minimum value, put x is equal to 2 by 3 in our given function, and by simplifying that will return a value 11 by 3, and this 11 by 3 is the minimum value of the given function. Fifth part is f of x is equal to 2x cube minus 2x square minus 36x plus 3. First derivative, by applying power rule, x cube, derivative of x cube will be 3x square, by multiplying to 2 will become 6x square minus 4x minus 36, and second derivative 12x minus 4. For stationary points, first derivative is equal to 0, and from here we will find the value of x, and this is a quadratic equation, and by using quadratic formula, this is just the explanation of simplifying this one, and from here we will get the value of x, which is x is equal to, by simplifying 2 dividing by 6, so x has value 1 plus minus square root 55 divided by 3. And now we have two values, x is equal to 1 plus square root 55 divided by 3, and x is equal to 1 minus square root 55 divided by 3. And now put x is equal to 1 plus square root 55 divided by 3 in second derivative. So second derivative, by simplifying this value, we have 4 into square root 55, which is greater than 0. So f has relative minima at x is equal to 1 plus square root 55 divided by 3. So f has relative minima, and to find that minimum value, we put 1 plus square root 55 divided by 3 in our given function, which is 2x cube minus 2x square plus 36x plus 3. Now just open the formulas of this cube and this square, and by simplifying 3 into 12 become 36, and simplifying that will return a value. This one just simplification, you people can easily simplify this one, and so this one is actually minimum value of the given function. Now we will check the second value, which is 1 minus square root 55 divided by 3 in second derivative, and by simplifying that return a value of minus 4 square root 55, which is a negative value less than 0. So given function has relative maxima at x is equal to 1 minus square root 55 divided by 3, and to find the maximum value we put x is equal to 1 minus square root 55 divided by 3 in our given function. So this one is actually f of 1 minus square root 55 divided by 3. So put the value of x in this given function, and simplifying that will return a value 1 over 27 minus 247 plus 220 into 55, which is a maximum value of the given function at this value of 1 minus square root 55 divided by 3.